To cut a long story short, this video is just about if you start seeing errors on your dash on the KTM and you spot that the oil temperature looks a bit funny or you're getting funny oil temperature readings, it's 99% going to be the problem is your oil sensor temperature is wrong, and you don't have to watch all this video, it's very long. Just go out and buy another one and swap it if you're willing to take the risk and assume it's just the sender, which it probably is. It's 300 Australian dollars. If you've got weird oil temperature readings, just swap it out. But if you're interested and you want to try and diagnose, or it could be another fault on the bike and you want to trace that fault somewhere, you can watch this video. Oil filler at the front here. You'll notice there's a cable that is tucked away around the back of it, and you trace it back up the top, and it's just plugged in here. So I've disconnected it and I've unzipped all the cable ties, and I've undone the two bolts down here, and you pull out the whole assembly and it's like one part. Obviously it's got oil. I suppose this bit at the bottom is the level gauge. Maybe it warns you when the oil level gets low. Might trigger an alert. But I suppose somewhere in here is also a temperature gauge. It looks like it's all one sealed unit. It does look like there's an Allen key on the end here, but the whole part is sold as complete, and it's 300 bucks, which is a lot of money. But what I've noticed is just down the neck here, it seems to have cracked, and there's like bits of plastic falling off. So yeah, in there, there's all broken away and frayed, and it looks like that red cable in there is possibly frayed. So yeah, you see how it's sort of chipped away a bit. So I'm going to strip this back and just see if there's a continuity problem, as in it's just the cable is snapped. And then I'll do some investigations to see if there's any chance we could repair it. Otherwise it's a whole new unit. So how do we know what are these wires and what are they doing? Well, luckily on KTM bikes, they label everything quite neatly, and in the manual you can work it out. So if you look closely on a plug, on here you can see 1, 2 and 3. So we know that number 3 is the brown and what looks like black wire, and number 2 is green and black, and number 1 is a mixture of what looks like light blue and green. Funny combination. Yeah, so we can work that out. Now, interestingly, on the sensor end, the wire colors are different, but the numbering lines up. So that's handy. So we'll have a look at the wiring diagram. We can work out what's what. If we look in the manual, under the wiring diagram section, there is a reference to oil level sensor and oil temperature sensor, B46. And if we look on the plan, we've got B46 here, and we've got 1, 2, 3, which matches our plug. And just by elimination, it looks like number 3 is just the incoming volts, probably from the ECU, and it splits off into 2. The middle one is what looks like the variable resistance, and if we zoom right in, I think that says T for temperature. And the other one is a simple on-off switch, which is probably the float level, which is on wire number 1. So let's put a voltmeter on wire number 1. So wire number 1 is red, which is what looks like the float meter. The one in the middle it's got like a clear cable, and you can see the wire underneath. It's number 2. That will be our temperature sensor, and number 3 is the black wire, which is the common. So we'll do the float sensor first. So we've got everything hooked up, and it's a simple on-off switch. So if you can imagine, when this is in the bike and the crankcase is full of oil, this should be floating at the top, and you can see it's basically infinite resistance. It's basically open circuit. And then if you have a catastrophic failure or you're not maintaining your bike well and the oil level drops so badly, the float goes all the way down the bottom and then it closes a little circuit and there's zero resistance. So that would probably send off an alarm on the dash or the ECU and sending there's a warning you're running out of oil. So that bit clearly works. No problem there. So let's have a look at the temperature sensor. So we'll just switch to the middle pin. And what I don't like about that's not a solid measurement. It's sort of floating. And also that's extremely high. That's 250 kiloohms. That's massive. And it doesn't seem to be stabilizing, it's just crawling along. So a bit suspicious. It should just be a fixed resistance. I might just have a look and see if we use a different voltmeter. So I plugged in another voltmeter. I was testing on this voltmeter to begin with, but I was getting the resistance was floating and slowly going up or slowly going down. Sure, it's a temperature sensor, so with ambient air changes it will go, float around, but this was consistently just dropping, and every time I connect it up it seems to be slightly different. But I think what you need to look at is the scale. This is reading basically 1 megaohm, which is massive resistance, and I've applied some heat with this hot air gun, getting it up to, almost too hot to touch without obviously melting the float on the end. And I'm not seeing any variation on this at all. It's flat. So I think it's got to be wrong. The resistance is quite high. So what do you do to sort of test or simulate that? So what I decided to do is, what the heck, let's just put a couple of resistors in and see if we can simulate different ranges of resistance, because I've got no idea what resistances should be running at. So in the end, all I've done is I popped in this is a 10,000 kiloohm. Yeah, this is a 10,000 k ohm variable resistor or potentiometer. You get these out of old radios, or you can get them from electronic stores. I've put the potentiometer in the circuit where it plugs into where the temperature sensor would plug into the wiring loop. You can see there I've basically got one side of the potentiometer, the black wire, going to the brown wire that comes in, and then the other side of the potentiometer, the red wire, goes into the middle pin, and that's the green and black cable on the wiring loom. Now I've got the tank off, so when we turn it on we're going to get lots of errors like MTC warnings and fuel sensor warnings. I've hooked up the voltmeter or ohm meter, whatever you call it, so we can look at the resistances in the potentiometer for a given temperature. Hopefully this will help you if you're, say, testing to see if the sensor works or not on your bike. So given the bike might be cold, just sitting in the garage, we can see what the resistance is like, say, for 10 degrees centigrade or 20 degrees centigrade. Or if you just come back from a ride and the bike, I don't know, is at 85 degrees centigrade, you can see what the resistance is by just sticking a voltmeter across the terminals and comparing what I've got. So what we'll do is we'll turn it on. We'll get a few errors: fuel pump error, MTC error. Okay, so it's showing 0 degrees at the moment, and I think it's on maximum resistance. So if I just slowly twist the potentiometer, there it goes. We've got 1 degree, 4 degree. Yeah, so if I turn it all the way up to the top, it's 150 degrees centigrade. So we'll just turn it down to, say, 10 degrees. There we go, so 10 degrees. Now I'll just take it out of the circuit, so I have to disconnect it temporarily. So at 10 degrees, we can see here this is on a 20k ohm setting. So this reads 4.6 kilo ohms or 4,600 ohms. So let's just try another temperature. Plug it back in. Yes, it's still around about 9 degrees. So we'll turn that up to, I don't know, 25 degrees. A nice warm day in some parts of the world. So at 26 degrees or thereabouts, the resistance is just over 2 kilo ohms, 2090 ohms. So yeah, definitely it looks like the potentiometer works, meaning I've got a problem with the oil sensor. So this unit is effectively faulty. So one's on order and we'll hopefully just plug it in and go, but it's $300. Hopefully it lasts a bit longer. We could, when I get the other one, I might open this up and see what's inside here. I've got nothing to lose, so I might undo the end there and just see if there's some sort of repairable item. I doubt it. Cool. If you're still watching this video up to this point, as a bit of bonus material, it might help in general troubleshooting electronic issues on your bike. What we'll do is just do a continuity check. Could be that the wire is frayed or split or corroded at the tip, so we need to make sure we're getting good continuity. So looking at the wiring diagram at the back of the manual, and you can see there's three wires. The number 3 wire I've worked out as being the supply voltage that comes in, and then you can see it breaks into two. One is a simple on-off switch, which is the float sensor, and the other one is this sort of variable graphic, which I think means temperature resistor. So obviously it changes its resistance, and that's the what looks like a green and black wire. So we follow that back, it goes off the page, and the way it works is that says a small T on there, probably for temperature, and it goes to diagram number 7, section F8, which is basically this one here, diagram number 7. We're in zone F8, and you can see T for temperature. So we follow that all the way back. Yeah, so it goes all the way back, and you can see here it's BLGN, which stands for green with a black stripe. Goes through a connector and then changes from what looks like green to brown stripe. And it goes all the way into this box here and joins in at number 16. Now this box here, A10, is the central control unit, and we can find out where that is on the bike by looking at the parts catalogue, and it's this thing here. So at the back of the bike, underneath the rear seat mounting point, so under the rear seat we have this plastic carrier. So you unscrew that, and underneath that plastic carrier is this unit, and you can see it's got 2 plugs, and then through deduction I've worked out this plug is the one. So what I've done is made up a simple continuity with the meter in continuity mode. I've got the one end of the continuity going into the plug here, and then with the probe you can hear so we've got a connection. So I've done the same for the other 2 wires. I've just probed each one and then looked at the number, and you can see on the back, as per the picture, there is numbers on these, so you can line it up with the diagram. So this plug carries the other one, which is the oil sensor, and that was on number so the oil sensor goes from here, followed up to the top, and that is O, probably for oil. And we come in on the next page and there's O. So we follow all the way up along and comes in at number 22, which matches the same position, and I get continuity. So there's no breaks in the wires. So now the only thing that could be wrong is this unit is faulty. or it's not getting a voltage to the sender. So we go back to our sensor, and we have this bottom wire, which I suspect is the feed, which is black and brown, and we follow that back up, and that's J, and J's here, so we follow that all the way up. So that's, was it number 3 in, so we go long, goes through a connector through here. Now it splices off, so this is why I suspect it's the incoming feed, because it's also supplying something else up here, which we'll see in a minute, and that comes in at number 9. So we have to do a continuity check on pin number 9. So same again, pin number 9, so we just count 1, 2, 3, 4, 5, 6, 7, 8, and so we've got continuity. If it's not number 9 on here, just check number 9 on this plug, because there is a way to determine which pin is going to which plug. I haven't worked it out myself. So I was finding I was trying to do number 22 on this, and I was getting no connection. And then I repeated it on this, and yes, the pin was on this one. So just test each one first before you think there's no continuity. Continuity? Yeah. So all 3 wires are connecting back fine. So the only other test we can do now to see if we're actually getting a volt coming into the unit, or voltage coming into the unit. So I've set the voltmeter up into measuring volts mode. This is quite a nice meter. This one does auto ranging. So we've got, what I'm thinking is the supply voltage coming in now, the ignition's turned on. So if we just earth that out, we should then get a reading. So what I do is I just tap that on there, and I'm getting a steady but very small millivolts. I don't know if that's enough. So if I just change the range here, so that's millivolt readings. It's pretty stable, like bang on 10, like 9.910. Take it off, and it drops away to 0. Put it on again, 10. But that seems incredibly small, like 10 millivolts is nothing. Maybe it's by design. So possibly the engine needs to be running. I doubt it, but yeah, I'll see if we can start it up and then do a test again. But I'm worried that that's a very low volt. I was expecting at least 5 volts. So I might just test something else that I know that does work and see what the voltage is on that. So again, we've got it on millivolts range, connected up to here. And if we then not short circuit, but we earth it out, so we get the voltage flowing through, it's the same, 10 millivolts, which is incredibly small. So whether or not CAN bus systems, which is what this is, have very low voltages because of the way it works. But it's exactly the same measurement, so all I can assume is that it is correct. I can't think of what else is wrong now, so the only thing is could be the electronics are stuffed, could need a factory reset, or, and now I'm going to have to do it now, is buy a new one of these for 300 bucks. So here's our new oil temperature and float sensor, or oil level sensor. Just an easy fix, just pop it back in. Comes with new O-rings, which is nice. In fact, I'll just put a little bit of oil on there so they slide down easily. Just makes it go in a bit easier. I won't pinch it so much. It's quite a tight fit. And these are 10 Newton meters. So again, not much. Unfortunately, I can't get on the back one, so I'm going to have to do that by hand, just by feeling the front one. Crikey, that's tight. Imagine snapping this off. So it's one of those jobs, just keep an eye on. If there's a bit of a dribble, maybe just give it a tweak. So that's that. And from the old one, we take the cap. They don't give you a free cap. Bit tight. And then zip tie this all back up how it was. There's a little hole there, you can see, that takes the zip tie, and then we feed it up through here. I might zip tie the wire around the neck so it's not flapping in the wind. It may be just fatigue has blown out. There wasn't one on there originally, but we'll just put one on there, it doesn't harm. One there, and then one at the top. So we'll turn it on. We'll turn it on for the first time. And ignore the not legal, that's my dongle. And the clock needs to be reset, that's all wrong. But as of yet, no errors. Yes, I think, what was it? Oh yes, oil temp, that's good. So oil temp is showing 19 degrees, which is the same as the air temp. So that means our new oil temperature sensor works. It's good. Okay, the fans have come on, so the fans are working. And we're at 88 degrees. Temperature, well, yeah, it's in the middle.